Okay guys, so what we're going to have a look at today is this follow on from our moles calculations where we're using balanced simple equations to calculate the amount or mass of a substance that we would produce in a reaction, or how much of a reactant we would start off with to produce a certain mass or a certain number of moles of a product. Today we're going to have a look at this phenomenon called percentage yield calculations. And a couple of things that we need to just define before we delve into what percentage yield actually is. So you need to understand two terms. First one you need to understand is the actual yield, and that is the mass actually made in the reaction. So in other words, if you reacted A with B and you were making C plus D, well, it would be the actual mass of C or the actual mass of D that you made. You take it out, you weigh it somehow, you work out how much of it you've got, and that is your actual yield. Now your theoretical yield then is a mass that you would expect to have made based on the moles calculations, like the moles calculations we did in the last video. So how do we work out the percentage yield? So let's say, for example, if I had A plus B for this one, C plus D. Well, if I started off with my moles ratio, remember, is 1, 1, 1, 1. So if I started off with 2 moles of this and 2 moles of that, I would expect to make 2 moles of that and 2 moles of that. So that is my expected yield. Your actual yield will be less than that. So for example, my actual yield here, I might only make 1 mole of this. Okay? So you're making less than you would expect based on the calculation, and we'll discuss why that is the case. So when you're trying to work out what we call our percentage yield, okay, the calculation that you have got to do is your actual divided by your theoretical multiplied by 100. So that's the calculation. You have to know that calculation. Okay, you then have to be able to calculate out your theoretical yield, and that's essentially doing the moles calculations we did previously, and the actual yield will probably be given to you in the equation. So let's see why there would be a difference in these two values of actual and theoretical. Well, if I take let's take an actual reaction, okay? So if I take a compound called ethanoic acid, which is the acid in vinegar, and I react it with ethanol, okay, I will get a compound called ethyl ethanol. Don't worry about the complexity of this. This is a GCSE equation. You probably just haven't met it yet. You may well have. Okay. Now, so let's say I started off with 60 grams of this, and I want to know how much of that I will make. Well, the moles of this is 1 mole of this is 60 grams, so number of moles is equal to mass, which is 60 divided by that. So I'm starting off with 1 mole of that. So therefore, I would expect to make exactly 1 mole of what we call ethyl ethanoate, because the ratio here is 1 to 1. We'll assume that this is in excess, okay, and therefore does not affect the actual quantity that we would make. Okay, now, therefore what we need to do is calculate what is the mass of 1 mole of this particular substance. Okay, well, we have, excuse me, okay, so it is 88 grams. Now, so therefore the mass is 1 multiplied by 88. Okay, so obviously that equals 88 grams. So in other words, if I had 60 grams of this, I'd expect to make 88 grams. Well, let's say the chemist who was doing it actually weighed out how much of this they did actually make, and they made 44 grams. So this is my theoretical yield. This is my actual yield, in other words, how much I actually made. Okay, so in other words, we've got to then do our percentage yield calculation, which is actual, which is 44, over theoretical, which is 88, multiplied by 100, so that is 50% yield. Now the question we need to understand as well is why, if I would have expected from all my calculations that I've done so far to make 88 grams, why am I only making 44? Well, the thing is that, first of all, this reaction is reversible. So it does not go to completion. Okay? So the reaction does not go to completion. So the reaction is what we would say incomplete. Okay? Why else? Well, you will have some loss in transfer. So doing this reaction to get your final pure product, you're moving the reactant, and you're moving the product from, maybe you're starting off with it reacting in a beaker, then you're filtering it, then you're maybe putting it into what we call a separating funnel. Okay, then perhaps you filter it again, and then maybe you have to dry it via some method. So all of these little methods, you lose a little bit of product as you go along, and that's called loss of transfer. The other thing is you have what we call side reactions in a lot of chemical reactions. So in other words, normally we just say A plus B to give us C plus D. Well, in actual fact, sometimes we get E plus F as well, but they're not important, and they're such small quantities that we don't include them in the actual equation. But nonetheless, if the A and B are being converted to E and F, they're not being converted to C and D. That's the important thing, I guess. Okay, so these are reasons why we don't actually get 100% yield. So you need to know the reasons, and you need to be able to do the calculations that to tell the examiner or show the examiner exactly what percentage of a yield you do actually get. Alright, so we'll do a few worked examples. Again here, once you think you've got them, guys, if it's probably best that you just pause the video, have a go at them, come back, check your answers with mine. Okay, so we have a problem on the board now that we're going to have a little look at. So the problem is posed to us. The examiner's told us we started off with 40 grams of magnesium and we made 1.7 grams of hydrogen gas. So we've got to work out our percentage yield. So remember your little equation, percentage yield equals actual yield over theoretical, or 100% yield, times 100. And also remember that mass equals moles multiplied by RFM. Okay, so let's have a look. The first thing we need to do, well, we made 1.7, so that is my actual yield. So if we go down here, we can just pop that in there. Okay, we need to work out what is our theoretical. In other words, based on this value here, how much of this should I have made? Okay, so number of moles of this equals mass, which is 40, over RFM of magnesium. If you go to the periodic table, you'll find that it's 24, so that's 40. Just leave that up there. 40 divided by 24 gives me 1.67 moles of that. Now if we take that across to our hydrogen, and it's a 1-to-1 ratio, yeah, that means I should make 1.67 moles of my hydrogen. Hydrogen has an atomic mass, or relative formula mass, of 2. Each hydrogen is 1, so it's 2. If you just multiply that by 2, means that we should, in theory, make 3.33 grams. So that, therefore, is my theoretical mass. So it's divided by 3.33, and that's multiplied by 100. Okay, so 1.7 divided by that multiplied by 100 is 51 percent. So you're only really making half of what you'd expect. So you have quite a lot of waste in this particular calculation. So again guys, once you think you've got these, it's probably best that you just pause the video and have a go at a few of them yourself. Okay, so we'll take this reaction here, which is the thermal decomposition of sodium hydrogen carbonate, okay, to give us sodium hydroxide and carbon dioxide. Okay, so we'll say that we made 25 grams of that. Okay, and let's say we started off with 150 grams of sodium hydrogen carbonate. So we're going to again work out our percentage yield. Okay, so we're looking at actual over theoretical, and actual is we made 25 grams of it. Okay, so theoretical is, well, we've 150 grams of that. Okay, so we've got to take 150 and put that over 84. 84 is the RFM of this, and that will give us a number of moles at 1.78 moles. If we go across, that will tell us we have a 1-to-1 ratio. Okay, 1-to-1. So that would mean we should make 1.78 moles of this. Remember that mass equals moles multiplied by RFM. So therefore that's number of moles is 1.78. The RFM of carbon dioxide is 44. So therefore we should in theory make 78.6 grams. We actually only made 25 grams of it. So 25 divided by the answer multiplied by 100 is 31.8%. Okay, so hopefully you're starting to cotton on to these. Right, so let's have a look at something else. So this time we will take an organic reaction. So if we take, don't worry about the complexity of this reaction, guys, okay, or the formulas that I'm using, okay, because really it shouldn't make any difference. The principle and the method is exactly the same for all of these. Okay, so we're going to say that we started off with 1.2 kilograms of this substance here. This is ethanol, and we're going to say that we made 500 grams of that. Okay, now the first thing that we need to be careful of here, and this is the first time I've introduced this, is that we have a 2-to-1 ratio. Okay, so whatever number of moles of this I start off with, I would expect to make only half of that number of moles of this product. Okay, so let's do our percentage yield. What it is, again, actual over theoretical. Well, our actual yield is 500 grams. Our theoretical yield we're going to work out now. Okay, so we have the RFM of ethanol here is 46, but remember this is in kilograms, so we convert it into grams in order to carry out the molar calculation. So the grams of that is 1200, and that's divided by 46 obviously, and that gives me 26 moles of that. Now if I have 26 moles of that and the ratio is 2 to 1, that means I should have 13 moles of this substance here. Now remember that mass equals moles, which is 13, multiplied by the RFM, so I need to calculate the RFM of this substance here. Okay, so that is 146. So that multiplied by that, so multiplied by 13 gives me 1898 grams. So this is my theoretical yields, and that goes down. It goes down there. Okay, so we've done the hard part really, and that tells me that my percentage yield is 26.3%. Okay, so really it's just a step on from the moles calculations that we were doing in the last section. Right, let's have a look at another one. Excuse me. So this time if we take copper sulfate and react it with sodium, we will get sodium sulfate and pure copper. This won't actually happen in reality really, but so don't be quizzing me on doing reactions that don't actually occur. Okay, it will serve the purpose to demonstrate the calculation quite well for us here. Okay, so let's say we started off with 100 grams of sodium and we made 12 grams of this product. Okay, so we've got to work out what is the percentage yield. So again, pause the video and do it, guys, if you think you've got this cracked by now. If not, please just watch and hopefully it will click. So we have number of moles, so again we'll just pop it aside. Number of moles equals mass over RFM. So mass is obviously 100, RFM of sodium is 23. Remember, it's just one sodium. Okay, so we have 100 divided by 23. So we're starting off with 4.34 moles of sodium. Remember, the ratio is 2 to 1. So therefore the moles of sodium sulfate that I would make should be 2.17. Remember, therefore, if we rearrange that mass equals moles multiplied by RFM. So multiplied by the RFM of that, okay, where the RFM is 23, okay, is 142. Okay, it means that I should have made 308 grams. This is going to be a really small percentage yield. It's going to be 12 over 308 times 100. Okay, and that gives us a really very small percentage yield of 3.89% only. Okay, right, we'll do another couple of these, guys. I think that will probably do us. Hopefully by the time we do that, you've got them sussed. Okay, so let's have a look. So we will do 2FePO4. So we've got iron 3 phosphate plus sodium sulfate that we had in the last equation to give us iron 3 sulfate plus sodium phosphate. Okay, so we've got nasty little formulas and nasty little ratios or reaction coefficients here. Alright, so what we're going to say first of all is if we started off with 25 grams of this, okay, and we're going to say that that's in excess to begin with, how much of this would we actually make? So we're just having to go back and do our equation or moles calculations like we did in the last video. Okay, so the RFM of this is 151. So the number of moles is 151 divided by 25. Okay, which is 6. So if we go across to my iron 2 sulfate, the ratio, if we look at it, is 2 to 1. So I would expect to make 3 moles of that. Okay, and we need to find out the RFM of this. So that's okay, and it's 344. Okay, so we've 3 moles of it multiplied by 344. Okay, which means I have 1 through 1. Okay. Oh, sorry, I've done that wrong, haven't I? Apologies. I go back. That should have been 25 over the RFM. I did that upside down. My mistake. Sorry. So we have 25, 56 plus 31 plus 64 equals 25 over 151 equals 0.166 moles of that. Again, it's a 2 to 1 ratio. So if we divide that by 2, we get the number of moles of that we should get, which is 0.828. Okay, and if we multiply that then by the RFM of this substance here, which is 56 plus okay. Okay, so I should make 33 grams of that. Okay, so the examiner then tells me, well, in actual fact you made 18.5 grams of it. Okay, so therefore I've worked out, this time we've had to work out the theoretical yield. Okay, and my percentage yield therefore is that divided by 33 times 100 gives me 56%. That's the yield that I would have expected. Okay, right, so we'll stick with this equation just for a little bit. So right, so if, let's say, the examiner says this time I start off with 15 grams of that, we'll assume that this is in excess. Okay, we get a 65% yield. So they're asking us this time how many or what mass of sodium sulfate would I produce. Okay, so if I have 15 grams of this, okay, so that is, okay, so that is 15 over 142, that's the RFM of this. Okay, gives me 0.1 mole of that. I would expect, now, only 65% of this number of moles is actually converted. Okay, but be very careful here, this is a 3 to 2 ratio. So if I have 0.1 moles of that, I would only expect 2/3 of it, okay? To be converted, which would make it 0.07 moles of this being produced, but only actually 65% of that is made, which is in fact 0.0457 moles. Okay, so that is what is actually made. That is what theoretically we make. So we can, this time, instead of having to convert these to mass, we can just do actual moles, okay, over theoretical moles. Okay, so that's 65%, obviously, but the question is, what mass of this will I make? Well, that's the moles of it that I actually make. So I've got to take moles and multiply by the RFM. So I've got to go back up here and work out the RFM of this. Okay, so the RFM of that is 164, and I've got to multiply it by 0.07 equals. So that gives me an answer of 7.5 grams, 7.48 grams. Okay, so there's a different twist on that question, guys, than there was on the previous percentage yield calculations. Okay, so we'll do another one similar to that, and hopefully most of you will be fine by then. Okay, so let's say this time we have 100 grams of this. Okay, let's say we get a 40% yield, and we're going to work out what mass this time of the iron sulfate we actually produce. Okay, as opposed to the other one, which was sodium phosphate. Okay, so right, so we've got 100 grams of this, so we need to work out the number of moles of this that we've got. So we've got 56 plus 31 plus 64. Okay, so the moles of that is 0.662. Okay, so we would expect, therefore, the moles of this, remember it's 2-to-1 ratio, we would expect to have that number of moles made. Okay, now remember it's a 40% ratio, so therefore in actual fact we would only get that number of moles of iron sulfate made. Remember from earlier the RFM of that is 400, so therefore we would make 52.9 grams, okay, or 53 grams would be fine. Right, so that again is how you would do that. Those last couple of guys are pretty tricky now, I think, for GCSE level. Okay, right. So let's say this time we have 200 grams of this, and we are going to make 100 grams of that. We're going to have to work out this time what is the percentage yield. Okay, so we've got to work out the number of moles of this, so it's 200 over 151, okay, which is the RFM of the iron 3 phosphate, right? So it gives me 1.32 moles of that. So I would expect, because remember it's 2-to-1 ratio, okay, you would expect to make 0.662 moles of that. Okay, we multiply that by 400, which is the RFM, gives us mass, and the mass therefore is 264 grams. So I would have expected to make, or my theoretical yield would be 264. So my percentage yield must be 100 divided by 264 times 100. Okay, which gives me 38%. Okay, so we'll take one last equation. We'll take magnesium reacting with sulfuric acid to give us magnesium sulfate and hydrogen gas. Okay, we'll say we started off with 2,000 grams of that, and we made 1,500 grams of this. So we'll just again work out what is our percentage yield. Well, again, number of moles equals mass, which is obviously 2,000 over the RFIM. Well, magnesium is 24. So let's have a look at that. That gives us gives us 83.3 moles. The ratio is 1 to 1, so it's 83.3. The RFM of this is magnesium plus, so it's 83.3 multiplied by 120, which means that I should, in theory, make 9996 grams. Okay, so that's my theoretical. I actually made that, so 1500 over 9996 times 100 gives me a small percentage yield of about 15%. Okay, now hopefully you are now equipped and able to do theoretical yields and using those then to work out percentage yields from the actual yield. You should also be equipped now to work out what the actual yield is based on the percentage yield if that is given to you in the equation.